This is chapter number 5. It's on the periodic table. If you want to actually see the periodic table in your textbook, it is on the last page. Okay. This is the whole periodic table. You will not be learning everything. In the next class, I will tell you what exactly you will learn from here. Okay. So this is the actual periodic table. This is called the modern periodic table. Okay. Now, about the periodic table. Originally, there were many scientists who wanted to make the periodic table. Okay. It was not called the periodic table. They wanted to arrange all the elements, okay, in a certain order. Okay. Now, till date, the number of elements that were discovered are 118 elements. Now, these 118 elements have to be arranged in a certain order. Okay. So, in the beginning, that's in the early ages, there were not 118 elements. They were all found, some of them were found little later. Okay. Now, those elements had to be arranged. So, first, the early chemists started arranging these elements, okay, not called the periodic table, okay, started arranging them. They classified these elements on the basis of, number one, properties. They looked at the properties of these elements. Similar properties were arranged together. Okay. So they considered properties. They considered valencies. They arranged some of these elements according to their valencies. And they also arranged it according to their metallic and non-metallic characters. Metals separately and non-metals separately. Okay. But this arrangement did not work out. Okay. This was by early chemists. Okay. So there were few people who wanted to rearrange this. Okay. So the next person who arranged this is called Dobereiner. Okay. The arrangement was called Dobereiner's Triads. Okay. Now, he arranged according to increasing order of atomic weights. He took the elements and arranged them according to increasing order of atomic weights. That is, the least atomic weights first, and then it kept increasing. Okay. And the highest number came later. Okay. So this arrangement was done according to the increasing order of atomic weights. And he arranged this in triads, means three elements put together having some relationship. Okay. I have given you an example of such a triad. Okay. You have lithium, sodium, potassium all arranged together. This is called a triad. Okay. Three elements put together. Okay. Now, how they are arranged is, lithium has atomic number 7, potassium has atomic number 39. Okay. And lithium has atomic weight 7, potassium has 39, and sodium has 23. Now, how these are arranged is, the one in the middle is the mean or the average of these two together. That is, if you add 7 and 39 and divide it by 2, you should get this. So 7 plus 39 is 46. Divide 46 by 2, you will get 23. So 23 is sodium. Okay. So this is how the triads were made. Okay. Now the defects about this arrangement in triads were, it was in a disordered manner. Okay. The arrangement was a disordered collection. Okay. It was not arranged properly. The second defect was, the triads were found not to be similar. In this case, yes, there is a relationship, but later on it was found that there was no relationship at all. This was never the mean. Okay. So this and this added together and divided by 2 never gave you whatever is in the middle. Okay. So the triads were found not to be similar. So this arrangement also didn't work out. Okay. So the third one, called Lens Law of Octaves. Okay. This is the third one. Newland arranged them not in triads, not 3 of them together, but he arranged 8 elements together, called octaves. Okay. This arrangement also was according to the increasing order of atomic weight. Previously also it was in the order of increasing order of atomic weight. Now also it is according to the increasing order of atomic weights. Okay. Now, what are these octaves? Now 8 elements were arranged together. Okay. And then every eighth element showed a similar property like the first one. First one and the eighth one showed similar properties. Second one and the ninth one, okay, showed similar properties. Third one and the 10th one showed similar properties. Okay. This is how the octaves were arranged. Now again, the problems about this, the defects were no spaces were left for undiscovered elements. Everything was arranged during those times, but new elements were found. Okay. Now when these new elements were found, they had no place in the arrangement which Newland had done. Okay. So no spaces were left for undiscovered elements, and it had some meaning for light metals but not for heavy metals. This arrangement showed some meaning for lighter metals, metals which were lighter, but it did not show anything for heavier metals. Okay. So again, this arrangement also didn't work out. Okay. So the next one, called Mendeleev's contribution. Okay. He is the one who actually found the periodic table. Okay. The actual periodic table which I showed you in the book is called the modern periodic table. The one which he founded was just the periodic table, okay, where his arrangement was according to, again, increasing order of atomic weights. He also arranged, this is the third person who is arranging it according to their atomic weights. Okay. And also, he arranged them according to similar properties appearing at regular intervals, which is called periodicity of properties. He arranged these elements, okay, according to similar properties. Those which have similar properties, they are all together. Okay. Some other elements which had different properties, but they were all similar. They were all arranged together. Okay. So according to similar properties also they were arranged, not only according to atomic weights, according to similar properties they were arranged and appearing at regular intervals, called periodicity of properties. This arrangement was called periodicity of properties. Now when you talk about periodicity of properties, what are these periodic properties? Some of these periodic properties I have listed here. They are, number one, called the atomic radius. I'll explain all this in the next class. First one is according to atomic radius they were arranged. Second one is called ionization potential. Third one is called electron affinity. Fourth one is electronegativity. And the fifth one are metallic and non-metallic characters. These are 5 periodic properties according to which these elements were arranged. Okay. Now, this arrangement had rows and columns. Okay. They were arranged in many rows and many columns. Okay. The rows which are horizontally placed were called periods. Okay. This way, whatever is arranged is called a period, and vertically if they are arranged, these vertical columns were called groups. This way they were called periods, this way they were called groups. Okay. So that was the periodic table that was made, and the defects about this periodic table is some having higher atomic weight were positioned before some having lower atomic weights. Because it was arranged according to atomic weight, okay, it was found that some of these elements which had higher atomic weight, they were placed before those which had lower atomic weights. So that arrangement was also not this one, not in order. Okay. So the last person who introduced the modern periodic table was called Moseley. So Moseley's classification. In the previous three cases you saw that the arrangement was according to atomic weights. But Moseley arranged this periodic table according to the increasing order of atomic numbers. Not atomic weight, but according to atomic number. Okay. So those which have atomic number 1 comes first, then atomic number 2, atomic number 3, atomic number 4, 5, 6, 7 and so on. They were arranged in order. And then it was found that that was the correct arrangement. Okay. So this arrangement was called the modern periodic table. It was called the modern periodic table. This table that you are seeing is the modern periodic table. Okay. That was arranged by Moseley. Okay. And if you see in this arrangement, okay, there are few of them which are arranged this way, that is horizontally, and few are arranged vertically. Okay. So those which are arranged horizontally in rows were called periods, like the previous one. There were 7 horizontal rows. If you see 1, 2, 3 like that, there are 7 horizontal rows and there are 18 vertical columns. There are 18 vertical columns. Each of this is called a group. This way it is called period, this way it is called group. Okay. So that's about Moseley's classification, which is the modern periodic table.